All right, welcome everyone. Thank you for joining Tech Academy's Tech Talk. Today we have Megan Vass here with us, and they're going to talk about core services principles using Node.js. So thank you for being here, and take it away.
Yeah, thank you very much. My name is Megan. I work in engineering and have for about 15 years in the microservices realm. I've been using Node.js since it was publicly available. And I've used it for anything from enterprise application design to robotics engineering. So that's a very brief, I've been doing it for a long while. Currently, I hold a position at Gap Inc. as a team tech and architect lead there for their content marketing automation division. So really that just means I run the team that manages all the tech stuff behind what the marketers create and it's showing up on the website, like cap.com. So that's a little bit of background about me. You can always find me on LinkedIn at /Megan-C-Vass. Feel free to send me a message there if you want these slides or the repo. The last slide will give the link to the repo, and I can put that in chat as well. All right. So this talk is about three distinct things: Node.js, microservices, and REST API design and infrastructure. This is a very, very large topic to try to tackle in one topic or in one talk. But these are the four things I'm going to try to get through today, and hopefully at least one of these principles sticks with you once we're done. So we're going to understand what it means to work in a microservice setup and architecture. We're going to break down a little bit of what REST does for devs and what it means in practice. We're going to learn some REST basics, and then we're going to explore a couple concepts that I think are pillars to how developers should approach microservices. So what are services? Within the context of computer sciences, services is unfortunately associated with a lot of different things. And it depends on the context that you're working in. So for us, we're talking about enterprise architecture and microservices. But if you were working in, say, an operating system, like a code base to improve an operating system, services are something very different, right? They're something that you can kind of access pragmatically within the operating system versus what we're talking about here, which is like network talk between two different applications to build a final result. So a more clear definition, a service is just a network accessible resource that we can call, right? We can interact with for it to do a specific thing, right? An action or cause work to happen. But the key thing is that it's reusable. It can be used the same way by three different things, right? And we don't have to guess how to use it or interact with it. And you can see, again, this definition is within the context of like microservices and network application design. So when we think about applications or like websites or even mobile apps and stuff like that, this is how we tend to see things, or most people tend to see it like this, right? You are a user on your device. You know you're going to go through the internet, right, to go use this service or this website or whatever it is, right? Could be YouTube, Spotify, doesn't matter what it is. This is kind of what we see in our brains, right? Like something very pretty simplistic. In reality, most of these things are built, like this. So we keep the first half because we don't need to really talk about that right now. But what we want to focus on is this left-hand application side. So in reality, it's not just like a cohesive piece of software that runs a lot of these things. So like, for example, Athleta.com, which is a brand underneath Gap, just to load their homepage, we have about 108 services, I think it is, that make the collective result that is like the Athleta homepage, because there's a lot of data and a lot of things that go into building that, right? So in reality, this is more what it looks like on the back end. And each of these services here, obviously a service or microservice. This architecture is definitely the more popular one from what I have seen over the years. And this is the pattern that we will be talking about today and kind of learning how to implement REST over this type of network and these service models. So to give us a little bit of context, I added names to these services. So you can see that like there's an operation, order of operations that needs to occur. But what this talk is specifically are these white lines that we're seeing here, right? These calls in between these services. How do we do that? And what does that look like? And like, how do we know it works? And that's more what this talk is like how to design those types of interactions between these different services. And that the answer to that is REST, at least in this talk. There's a lot of different API standards out there. So getting to know REST, REST, like I said, is one of many standards for APIs, but currently it is by far the most popular architecture around providing API services in a consistent and reusable fashion. Others that you might hear are like SOAP APIs, or GraphQL is another popular one. These are all different API standards that just dictate how services talk to each other. And REST is just another one of those standards. So this is what we just saw, right? We've identified these white lines as REST API calls because that's the architectural standard that this talk is about. So what is a RESTful service? It's an API that conforms to the design principles of what's called the representational state transfer architectural style, which is a lot of very long words. For it to basically mean everything should just be self-contained and shouldn't have to know about anything other than itself to answer a question, right, for a call. That's really all it is. Again, there's a lot of different formats and the data, like data kinds, right? So the most popular being JSON as a transport, XML was used previously, raw text. Those can all be the return formats of a REST API, but definitely the most popular is JSON, and the most standardized is around JSON. So, like I said, this is a very large topic to try to cover in one talk. So there's 5 core REST principles that are defined in the actual spec for this architecture, and we're going to get kind of a very quick crash course on what these principles are and how they apply to the models that we've seen. All these definitions and everything came from the IBM REST APIs spec, and you can find the source up at the corner. One is uniform interfaces. So we touched on this very briefly when talking about these requests, that like every service should be able to interact with one service the same way every time. And this is a core tenet of REST. So when we take a look at this structure here, in this particular case, like ordering service should always be able to call the inventory service the same way, right? The data or the IDs that it might call or the information it might provide might be different, but the structure of how that information is handed to the inventory service is always the same structure. And that's what we're really after with REST and really any API interface architecture, right? These things dictate how we interface with each other. And this is key. So right now, we don't have a service that is called by 2 different services. But for example, if user data also had to call inventory service, it should use the same structure as the ordering service did for that call. And these things can also be known as contracts, very commonly used when JSON is involved. Number two, server or client-server decoupling. Client-server applications need to be independent for REST to function appropriately. So generally, when we interact with REST services, the concept is all of the information that we need to process your request or your work or whatever it is should be in that first initial payload or in the URI or URL. We want to reduce the amount of work every service has to do externally with other services as much as possible. The way I define this is you should have all of the data you need to do what you need before you send it anywhere. And this is harder than it sounds, right? Because a lot of services have a lot of different data sources or ways they can get data. And this is definitely a challenging thing to keep in mind when you are building these systems. So another example here, total decoupling, like the UI render service here, doesn't even know that the payment server exists, right? It's entirely isolated from it. And vice versa. The payment service has no idea what the UI render service does or anything like that. Like there's no reason for those two services to talk to each other. However, when the UI render service makes the call to ordering service, it's doing it with all of the information for all of that it needs to make the two preceding calls to payment service and inventory service. This is normally called like data enrichment as you go down the service chain. But again, UI render service doesn't have any concept of payment service, and that's generally what we like, what we want, right? Because that means any other service can talk to payment service like any other service, without caring where they are on the chain or how far they are along the chain. Statelessness. So a good dovetail. This is also known as fire and forget in a lot of scenarios. This essentially means when a REST call is made and a response is given, the REST service itself no longer knows anything about that request, right? It processed it and then it gave the response and it said, I'm done. That's all I have to do. It's not going to retain any function or any memory of like that transaction to pick up again later. And this is what we call, referred to by like statelessness, is that you should be able to always make the same calls with the same data or different data to this REST API, and that data shouldn't change. And this means that REST APIs don't normally interact directly with things like users because they don't have the ability to retain things like sessions or cookies or anything like that. So REST APIs are generally stateless. And this, again, just reinforcing with our model, all relevant data got passed along when we made that first request from UI rendering service. And then it got enriched by ordering service. And then a call was made to inventory service. But again, like inventory service doesn't even have a concept of user because it's entirely stateless. So we just ask for an inventory item and we don't care what that's related to. Cacheability. This is something I deal with on a daily basis at work. So when there's static sources that are being returned or data sources that don't change very much, we can cache it. So caching is basically the equivalent of keeping a copy close to the application because you normally get that information from an external source. But if you keep it close to the application, it's faster to get, essentially. And this is a forever fight with REST APIs. But it's also a very big tenet of how we deal with performance in REST APIs, right? The easiest thing we can do to make stuff faster in a stateless environment is to simply get the same result right? Again, but faster. So we can do that by storing the calculated result and then returning that when that request comes in instead of doing all that recalculation. And this can happen in a lot of different ways, in a lot of different scenarios. So like the UI render service here, it doesn't really have data, right? But they do have a lot of static things that they serve, which these days is probably like a React app that's building out fragments and rendering these pages. Well, all those HTML fragments are that aren't like customized or they show up on every page. They can all be cached. And this again is important for speed, right? Because if I have to go reach out to like AWS, CDN, or the internet for this piece of information, or it's going to take longer, or I could reach to like a database that's directly next to my service in my infrastructure. But the same principles work for data as well. The ordering service probably has a database, right? If we know database records don't get modified, we can cache those. These are all different scenarios where we can look at how to store data closer to the services. 5-layer system architecture. We've been seeing this already from the first diagram. And really what all this means is, right, that all the services in between the calling service and all the services in the back that were needed to get a response total for that first call, again, shouldn't be aware of each other. And it shouldn't matter where they are in the communication loop. And we saw this with that first diagram, right, where it was a bunch of services inside of the big box instead of application. Because like your phone, for example, doesn't care that there's a bunch of services behind the endpoint that it's calling. But there is a bunch of services. But the fact that it can't distinguish that is the key principle of REST in this case. This back to our old graph, right? Like service 5 doesn't know service 1 or 3 exists. It only knows about calling service 4 and service 2. I do have a little bit of code that we can actually look at and run a little bit, and I can show you some core principles that aren't part of the architecture spec, but I take to all the jobs and all the systems that I design. This is the biggest one, traceability. And it's a lot harder than one might think, actually. So the idea is all those white lines that we were looking at, all those REST calls, how do you know they happened and order that you think they happened in? This is overseen a lot in a lot of the shops I walk into. They can't tell me what their services are doing. So back to our little graphic here, right? So how can we prove these requests happen? And like, how can we show they happen start to finish? So I have code here. This is a very small service. It does not do a lot. Here's a postman that's going to just hit our service help checkpoint. We can see that it's alive, right? So we know the service is up. It's good. And then we can look at the headers. And the important part is this right here, this trace ID. So let's run a quick example of what we just did. So this is the route, the logic that runs when we hit this API, this API endpoint. And traceability, what we're after here, is done via these headers. But they're also dumped out in these logs that you can see down here, these trace IDs right here. This is a really easy way to keep track of things. If you attach an ID to every request in your services, it's very easy to identify them. We do this here with a middleware that adds that ID. So essentially what this does is we look for the ID. If we didn't find it, we make one. We attach it to our request. And if there was one that was already found, we actually just reuse that. What this does is this means when a service calls another service, it will already have a tracking ID associated with it. And what this will do is cause this ID to bounce between all of your services, which then makes that ID show up in all of your service logs, so you can search for it. In your logs when you make a request. So we can see here we only made one request. Let's take it a step further though. Let's call a different route real quick. So there's one called show trace. It's very much like health check, but it just returns the trace ID that was generated for this request, right? For this transaction. And then we have another API here, and it calls the same, it calls the show trace, the one we just did, but with a header that already has an ID generated. So we'll be able to like take that ID, search our logs, and see that two different routes were hit, but the trace ID is the same. And this essentially allows us to track our interactions from service to service. So you can see it shows up in two different places. The internal API call route, but then it was also forwarded to the show trace route. So now we have logs that prove that our internal API logic called our show trace route and provided a trace header. And this is what allows us to trace what happens in these large ecosystems with these services. And again, I know it's a lot to pull in. And if nothing else, just take away that you should always log some unique identifier about a request, because chances are you are going to have to go back and find a request at some point. This is the graphic for what we just did with code. We'll get to external API in a minute. The other half of that tracing is we're going to get a cat fact real quick. So we have another route here that calls to catfact.ninja, which is a free API, and gets us a cat fact. Now, the key thing here, though, is that trace ID that we generated here gets sent with this request to the external API. So we can see here, we're going to cat fact, right? We're going to hit their API, but we're also providing this header. Now, in this case, it's a free API, but in an enterprise setting, when you have systems that are making calls to external APIs or external vendors, you're going to have to be able to provide them some information that they can look for in their logs about your requests. So this is a way for you to go to these third-party companies and say, hey, I'm consuming your API. I'm having an issue here and I don't know why, but here's the ID of the request I sent you that you can find in the headers, right? So it's not only traceability for you, it's traceability for anyone you integrate with as well. Ease of creation. So this is less about the actual API standards, but how quick can you manage your code base? So APIs get big. They get really big. Sometimes definitely too big. Ease of creation is a good metric for how easy your systems are to work in. So like right now, my devs can put a new service in production inside of 4 days, which for enterprise is reasonably exceptional. Most enterprise situations, it would take a month more to just get a new service created, let alone like deployed anywhere. This is again a developer keeping the back of your head type thing, right? If it's overly complicated to create a new feature or write new logic, you probably need to reevaluate how you've structured that project or that API. Logic boxing. This is essentially refactoring, but try to do it before you need to refactor, oddly enough. Another developer presence of mind thing. And this will affect your services. So in our code, an example of logic boxing is this, our header ID here. Constants is a very familiar and common thing we do, where we set a bunch of static values. This static value is used in multiple places. So it made sense to box it by itself, right? So it can be brought in multiple times by multiple different things, but still be used all the same. And you can see this in our routes. It gets pulled in here and here. So instead of defining that one string multiple times, we put it in one place where it can be accessed multiple times. This also means, if we change it here, it changes everywhere. We don't have to go search our code base and like a maintenance nightmare, if you will, to try to find all of the times this string is found inside of our repository. So logic boxing. Refactor while you're writing code. Don't do something poorly and then hope you get time to go back and do it. We blitzed through that pretty quick because I wanted to allow more time for questions because there's a lot of information in here.
Yeah, thank you for that. We can open it up to questions. Let me know whoever has a question. I don't see anything in the chat yet. If you want to raise your hand, I can unmute the mic and let you go ahead and speak or share your question, and we can go from there. But maybe you need some time to come up with something. So I'll just start ahead. We went a lot of information, and some of our students are a bit they're beginner, and I was wondering, what are some good resources where you can learn more about these topics, either on like some of these learning platforms, LinkedIn Learning, etc.
I've actually found LinkedIn Learning to be pretty good. Admittedly a bias, I do have an article that's on there that I'm sure it's floating around from years ago, but it is pretty good in my opinion. There is a lot of more relevant information because it tends to be written by people that are currently working, so you don't get stuff that was a standard like 2 years ago. But the danger with that is that you're also learning something brand new and you don't necessarily know if it'll be super useful. Udemy, strangely enough, I think is actually the best like paid learning service like per class around that has the most up-to-date and best courses around like REST and API development. That being said, there are a ton of free resources. You can actually go to any open source project, find the top 5 contributors, and track down to see if they've either made a class, what they post on LinkedIn, or other socials, or if they have a blog. That is really the 3 ways that I tend to keep in communication with what is happening. Because it is impossible to keep up with everything new that's coming out. Like it's going to be rough. But pick, I would say, the 5 experts in what you want to do, and go through their LinkedIn, find their blogs, and then sign up for a newsletter. Like if you want to know about JavaScript, go sign up for JavaScript newsletter. I'm literally read an hour out of that newsletter every day about whether it's Dino, which is supposed to replace JS, new versions of Node, whatever the latest security issues are. That JavaScript newsletter is very, very good at keeping you in the know, including with like security issues, bugs, things that got rolled back on these, because we all depend on this huge infrastructure that none of us really control, right? Like NPM and all these package services. You gotta keep your ear to the ground, and that JavaScript newsletter is by far the best way to do that, in my opinion, for this ecosystem.
Wow, that's a great resource. Also, I think it is Udemy that they have discounts. So sometimes if you wait for the course to go on sale, it's definitely going to be cheaper. You just have to wait around for it usually. Um, R. Anderson has a question. What about coupling and decoupling in reference to service application? Services
Uh,
application.
this gets harder and harder as time goes along, to be honest. So in the world of React and server-side rendering, um, decoupling is become like we're kind of going backwards in a weird way with that, like because we're getting React that's tightly down to like API calls now, because it's all in one service. I don't personally care for that, and I'm not a particularly large fan of React, but again, a whole other talk. So I think the question you need to start with is, does your service have to deal with the UI? Like, is there a UI involved, or is this simply a data transaction? And that's where you have to start with coupling and decoupling, because if it's a UI, they have to be at least loosely coupled. But if it's a data API only, they can be very like full RESTful stateless instances and be totally decoupled within the enterprise like network application space.
Got it. Let us know if there are other questions. Also, you just mentioned something taking over JavaScript, a new language.
Oh,
Is there anything?
so the inventor of Node, the original inventor of Node, has a new language, a processor that they're toting, which is called Dino.js, which is essentially Node.js sans all of the regrets the original developer had about Node, and then current technology more involved. It has its ups and downs. I think the most controversial point is the fact that you're required to use TypeScript, like it comes baked in, so you don't have any other option. Which I don't think that war will ever really be over. TypeScript versus Babel, all that, right? Like everything we did today is just raw standard JavaScript.
Got it. I don't see any questions as of right now. Like I said, it might be a little complicated to talk for some of our students, but are there some questions they should be asking in your opinion on this topic?
Yeah, absolutely. I'm a big fan of the daily exercise thing. Well, I call it the thing because it floats around my head every day. Pick a business and then try to freehand draw all of the services you think you need to make that business run on a technological level. And it doesn't matter how big or small. I don't care if it's the mom and pop plant shop across the street or how you think Amazon runs their services. Because what's going to happen if you do that every day is you're going to find all these simple things are not so simple to achieve, arguably, right? Because you're going to start running into strange things of how do I do this or how do I do that, such as how do I schedule jobs? How do I send emails? Right? And these are how you identify the holes in what you do and don't know in like that enterprise application space. And you can do this for a lot of other things. It doesn't have to be for the enterprise network applications. It could be, I want to plug a peripheral into my computer. How do I think I need to do that? But those thought exercises are very, very important.
Got it. Also, not to fully change the subject, but you know, a lot of our students nowadays are trying to land jobs. We do have mostly full stack developers, but there are other students who are in the JavaScript boot camp and other boot camps. But in the full stack developer boot camp, JavaScript is included. Do you have any tips for someone trying to go into the work field right now in tech?
Learn something other than React. Learn Vue, learn Angular, learn literally anything. Um, the largest issue I see with new students most of the time in my interviews is that they learned React, they didn't learn JavaScript. And that's really harsh, and that's not their fault. But I would highly encourage to invest your own personal time into getting just a JavaScript book. Not React, not a framework, just JavaScript. Um, that is the most valuable thing I see in most of the candidates coming in, is arguably self-education. Tech schools are good, colleges are great. None of us can know everything, right? So it's always about that self-education, which I suppose is arguably a soft skill that I would argue is very good to demonstrate in an interview, right? Even if it is just bringing up like, oh yes, I was reading about this, or that you do know that newsletter, that you are involved with the technology. Because I can teach anyone to write code, but I can't get someone to be invested in something when they're not.
That's a very great tip. Thank you so much. Especially the book. I think a lot of us nowadays, you just go online, find the information we need, and just kind of skim over all the important parts that we don't think are important, and that's kind of where we get lost. Any books that you recommend for JavaScript?
JavaScript in 24 hours. Like it's a pretty light read. It's not super big, but it is general, like just JavaScript. And it's like how to just do basic things in JavaScript. That like if you're on the Node side, you definitely need to know how to do. But if you're on the React side, it will just enrich what you can do inside of React because you know the language, not just the framework.
Got it. And then we have a question in the chat. Which JavaScript framework do you recommend for beginners, if not React?
Oh, that's a good one. I am actually partial to Vue right now. I think they strike the best balance between being extremely rigorous with their framework and then also providing like way too much freedom to where it's like impossible to get anything running. I think Vue hits kind of in between that right now, which is why we do see a lot of businesses moving to Vue, especially for their micro UIs, which again is like a whole other talk.
Yeah, thank you. Let us know if you have any other questions, but if something comes up, you said LinkedIn would be a great place to connect with you, right?
Oh yeah, always. Feel free to add me as a connection, shoot me a message, and I can get you these slides. The code that I showed today is all available. It all runs, so feel free to reach out if you want.
Great. I'll put your LinkedIn in here. And also, if you guys want to watch this recording back to, you know, go over some of the information we went today, I will be posting it. Excuse me. I had to scratch my throat for the last few days. Wait, I won't start a cough attack, but excuse me. All right, so I'm gonna post it later today or maybe on Monday, but it will be on our YouTube channel, and I just provided the link there. Excuse me. All right. And also next week we will have another tech talk. It's Chris Thompson. They're going to be talking about prompt engineering. So if you're interested in that, here's a link where you can download that. Any final thoughts, Megan?
I just put the link to the slides and the repo in the chat if people want to grab them real quick. But that's really it for me. I hope at least one of these tenets sticks in the back of your brain for when you're out writing code. You know, you hear my voice echoing in the distance of like, make it reusable.
Thank you so much. It was a
Yeah,
lot of informative information. I really appreciate it. And also, thank you all for joining us. And I hope everyone has a great weekend. And I will see you guys next week. Thank you again, Megan.
thank you all.
Bye, guys.